All right, let's dive into one of the most powerful tools in C++, user-defined functions. We're going to see how you can use them to take your code from, well, a bit of a disaster into something that's clean, organized, and way more powerful. So, does your main function ever look like this? Just one giant, tangled block of code that seems to scroll on forever? If you're nodding right now, don't worry. We've all been there. And today, we're going to fix that for good. So here's the game plan. We'll start by talking about why that giant block of code, that monolith, is a problem. Then we'll introduce functions as our solution, kind of like recipes. We'll see how they handle ingredients and give you back a finished dish. We'll get into the nitty-gritty of passing data, organize our code's world, and then we'll finish up with a couple of pro-level techniques. Sound good? Let's get cooking. Okay, first up, the code monolith. This is that classic situation where you've just stuffed every single line of your program's logic inside that one main function. And look, it might work for a hello world program, but as soon as things get even a little bit complicated, it becomes an absolute nightmare to read, debug, and manage. So why are functions the answer? Because they let you take a huge, scary problem and just smash it into tiny, manageable pieces. This makes your code modular, which is just a fancy way of saying you can write a piece of code once and then reuse it all over the place. This is a total game changer for testing and updating. And if you ever work on a team, it's absolutely essential. The end goal here is to make your main function look like a clean table of contents, not the entire novel. So how do we get to that beautiful, organized code? It's all about functions. I really want you to think of functions as the individual recipes in your code's cookbook. Each one has a very specific job, a clear purpose, and a set of instructions. And that's really all a function is at its core. It's just a named block of code that does one specific thing. Instead of wrestling with one giant problem, functions let you focus on solving a series of smaller, much easier subproblems. Honestly, this is the secret to good software design. And using them is a super simple two-step process. First, you define the function. This is you writing down the recipe, step by step. Second, you call the function by its name anytime you want to use that recipe. It's that simple. You define it once, but you can call it 100 or 1,000 times. Of course, recipes need ingredients, right? And sometimes they actually produce a finished dish. So let's take a look at how our code's recipes, our functions, get data in and out.
Now this is a big one. This trips up so many people, so let's nail it down. A parameter is the placeholder in your function definition. It's the recipe saying it needs eggs. It's an abstract idea. An argument, on the other hand, is the actual value you give the function when you call it. It's you in the kitchen handing the recipe 2 large brown eggs. See the difference? The parameter is the slot. The argument is the real thing that fills it.
Functions also tend to come in 2 main flavors. You've got void functions, which just do something but don't give you anything back. Think of a preheat oven function, it just performs an action. Then you have fruitful functions. These are the ones that do a calculation and then return a value that you can catch and use later. And this brings up a really crucial point. Printing a value to the screen is not the same thing as returning a value from a function. One just shows you something, the other actually gives you a result to work with. Okay, so we know how to get data out of a function with return values, but let's look closer at how we get it in. When we pass an argument to a function, how does C++ actually hand over that information? Turns out there are 2 fundamental ways, and the difference between them is absolutely critical. By default, C++ uses something called pass-by-value. The easiest way to think about this is like giving your function a photocopy of your data. The function can scribble all over that copy, draw on it, tear it up, but your original piece of paper is totally untouched. It's really safe. The other way is pass-by-reference, which you signal with that little ampersand symbol. This is like giving the function the actual original document. It's way more efficient, especially for big chunks of data, but it comes with a pretty big warning label. And here it is. When you use pass-by-reference, any change the function makes to that parameter is actually changing your original variable back in main. This can be really powerful if you want it to happen, but if you're not expecting it, it can lead to some incredibly confusing bugs where data changes mysteriously. So the bottom line is use it, but use it wisely. Okay, we've got all these amazing recipes, our functions. How do we organize the whole cookbook so the compiler knows what's going on and where to find everything? Well, this is where 2 concepts, prototypes and scope, come into play.
A function prototype is basically just a heads up for the compiler. It's a single line of code. You usually stick them at the top of your file, and all it does is say, hey, compiler, just so you know, a function with this name, this return type, and these parameters exists somewhere. You'll find the details later. This is awesome because it lets you put your clean, readable main function right at the top, and all the messy implementation details can live down below.
Next up is scope. Scope is just the rule that defines where in your program a variable is actually visible and usable. Think of it like a kitchen pantry system. Some ingredients are on the main counter, global, for anyone to use. Others are tucked away inside a specific drawer, local, to that one recipe, and nobody else can even see them.
So when you use a variable, how does the compiler find it? It actually follows a very specific search path, always starting from the inside and working its way out. First, it looks in the most immediate set of curly braces you're in. No luck? Okay, it widens the search to the entire function you're in. Still can't find it? Then, and only then, does it look in the global scope, outside of all functions. And it always stops and uses the very first one it finds.
All right, we have covered all the fundamentals. You are ready to cook. But before we wrap up, let's just peek at 2 more advanced techniques that can give you some serious flexibility and power. First is function overloading. This lets you create multiple functions with the exact same name as long as they have different parameters. This is so cool because it's really intuitive. You can write an add function that just knows how to handle 2 integers or 2 doubles or maybe even 2 strings. C++ figures out which recipe to use based on the ingredients you give it.
And if overloading is like having a few similar recipes, a function template is the ultimate master recipe. With a template, you write the function logic only once, using a generic placeholder instead of a specific data type. Then, the compiler does the magic for you. It automatically generates the perfect version of that function for integers, doubles, strings, whatever you throw at it. It is literally write once, use for anything code.
Okay, so let's bring it all home. What are the big things to remember? Number 1, use functions to break down big problems. Think in recipes. Number 2, define them once, call them as many times as you need. 3, be really deliberate about how you pass data. Pass by value is your safe default, and pass by reference is for when you need efficiency or need to change the original. And finally, keep your code organized with prototypes and always have a clear understanding of scope. We've just handed you the C++ recipe book and shown you all the core techniques. You now have the power to write code that's not just functional, but clean, organized, reusable, and so much easier to manage. So really, the only question left is, what are you going to build with it? Thanks for joining me.